going to take a look at writing and evaluating algebraic expressions, meaning expressions that include variables. Now, a variable is a symbol that takes the place of a number. So here's a collection of variables, and I gave them meanings. And you'll notice all of them mean a number. So C is the number of classes in a school. Not classes, the number of classes. If it wasn't a number, it wouldn't make any sense. And that does have a value, and I did give it here, but we could change that if we felt like it. The number of schools in a state is S. There are 100 of them. B is the number of boys in a class, or 15. Girls, the number of girls in a class is also 15. Doesn't have to be. L, it's not the number of, in this case it's a cost, but that is a numerical value. The cost of lunch per student, $1.50 a kid. M is the number of students that fit on a bus. Interesting. 25 kids. So, in English, what does the sum of the number of boys and the number in a class and the number of girls in a class mean? Well, that would be the number of students in a class. Alright, some statements mean something and some don't. You'll notice this is not one of the variables. This expression means this. You could say the total number of people in the class if there was no teacher anyway. Now how would we evaluate that expression since we do know what these variables are? Well, in order to do that, we're going to use something called substitution, which is, right here. Substitution. Substitution means to replace an expression with an equivalent value. So in this case, we're told that the number of boys in the class is 15, so we can substitute that. So replacing B, we will use parentheses because we're making a substitution. And if you look at my little tip there, always use parentheses when making a substitution. So this is the number of boys plus the number of girls, which is also 15, that will become 30. Alright, so if you're going to make a substitution, you must use parentheses. There's so many errors that happen when you don't. In this particular case, not much could go wrong, but there will be situations where that happens. Always, 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 always use parentheses when substituting. Let's look at another example. What does this mean? B times G, the number of boys times the number of girls. We can calculate that. That's 15 times 15, which is equal to 225. I don't know what this value represents. This is 15 girls of boys. It doesn't make any sense. So this does not mean anything. Has no meaning. And some expressions don't. If it doesn't make sense, it's probably not meant to be written. But you need to be able to identify if your expressions make sense. You should read what you write sometimes. If you were supposed to write the total number of kids in a class and you wrote B times G, you'd have to think about, does 15 boys times 15 girls make sense? And it doesn't. Let's look at another example. Alright, so this is the total number, as we already discussed, B plus G is the total number of kids in a class, and C is the total number of classes in the school. So this expression is the total number of children times the total number of classes, which would mean the total number of kids in a school. Okay, so you can see these could be written as a single sentence, if it makes sense. So that's 50 times, don't hesitate to use extra copies of parentheses to make sure that everything comes out okay. Alright, so that's, the order of operations says we have to work inside the parentheses first. 15 plus 15 is 30. So that's going to be 50 times 30, which is equal to 1,500. So there are 1,500 kids in the school. Let's take a look at another example. Alright, so what does this mean? This is the total number of classes times the total number of boys times the cost of lunch per student. Alright, so this part means the total. This is the lunch for one class. This is the lunch for the whole school. So this is the cost of lunch for all boys. So this is lunch for all boys in the school plus the lunch for all girls in the school, or the money for all the lunch for the girls in the school. So this is the total cost of lunch for all students. And I'm going to need a little bit more room to evaluate this. So this is 50 times 15 times $1.50 plus 50 times 15 times $1.50. Now the order of operation says that multiplication comes before addition, so we'll have to do that first. 50 times 15 is 750 times $1.50 Okay. $1.50 is the same thing as 1 1/2. So this and another half of this. Half of this is 37.50. So this should be 3. Not very good without a calculator. Let me bring the calculator on screen here. There's nothing wrong with using a calculator. So that's 750 times 150 is 1125. Alright, so that's 1125. All that is plus this value, which we know is also 1125. So that's a total of 2,500. And in this case, because this is money, this is dollars. Let's look at another example. C times M. That's the number of classes in the school times the number of kids that fit on a bus. I don't believe this means anything. This means nothing. Alright, because classes don't represent a number of children, whereas the number of buses need to deal with children. So it would have to work with B or G in this case. Alright, in this case, this is the total number of boys in the school plus the total number of girls in the school, or the total number of children in the school, divided by the number of kids that fit on a bus. So this would represent the number of buses needed for one school. This is all of the students divided up onto some number of buses. Alright, so that would be 50 times 15 plus, again, 50 times 15. All of that's over 25. So 50 times 15 is 750. So that's 750 plus 750. All of that's over 25. So that's the multiplication. Now the addition in the numerator, because again the numerator is a grouping symbol, we have to complete the numerator. That's 1500 over 25. Now we can divide. 2500 goes in here how many times? I'm not very good with my basic calculation skills. I need to work on that. 1500 divided by 25 is 60. So in order to get every student home on the bus, we need to use 60 buses. Alright, let's write an expression that represents the total amount of lunch money made by the school. Alright, so that's the number of boys plus girls, the number of boys and girls in one class, times the total number of classes, times the cost, so that's the total number of kids in the school, times L, which is the total amount of money made by the school. So this expression would mean this. We could also have written LCB, which is the total amount of lunch money brought in by the boys, and LCG, which is the total amount of lunch money brought in by the girls put together. These expressions are the same. They both mean it. Write an expression that represents the number of fingers all the students in the state have. Interesting. We're going to assume that all the students have 2 fingers, which makes, I think, is a reasonable assumption. Alright, so B plus G is all the kids in one class, times C would be all the students in a school, times S would be all the students in the state, times 10, because of how many fingers they have. We can calculate that. That's 10 times 100 times 50 times 15 plus 15. And we can evaluate this expression. 15 plus 15 is 30. Alright, working from the outermost part inwards. That's 15 times 30, so that's 4,500. And that's 45, moving 2 more zeros. We're multiplying by that 100, so that's 450,000 times 10 is 4,500,000 fingers of the kids in the state. Alright, I'm actually going to let you guys do this example on your own. If you'll just pause the tape and try it yourself. And just make the substitutions as necessary. And then evaluate using the order of operations. Okay, let's take a look at another example. In this case, we're asked to evaluate the following expression when x is... Sorry about all this. Let me get rid of that. Alright, so we're asked to evaluate this expression for different values. So we can substitute 1, and that's 3 over 5, which is the same thing as 0.2, that's 0.6. So that's 0.6. But we could do this faster with a calculator. We can call this y, or f of x, either way would be the same, and calculate different values for y given different x values. So if we plug this into a calculator in the y equals mode, 3x over 5, we can look at the table by pressing second graph and see with different x values what are the different y values. So when x is equal to 1, we get 0.6 like we said, and then 1.2, 1.8, 2.4. So that's 0.6, 1.2, 1.8, 2.4, and 3. Alright, so that's another way to use your calculator to evaluate expressions faster by setting them equal to y.